to say that this topic and this method is very, very new, how can I say? And it was a very, very big challenge for us to get with this kind of visual technology. So this is the things that we are going to talk about. First about introduction, classification, AR and GIS, tracking system, marker detection, AR implementation, and of course our project that is very interesting. You will see. These are some quotes. For the first quotes, I'm sure that all of you have heard. It's very popular, and but most interesting for me, in my opinion, is the third one. If an interface is worth 1,000 pictures, then a geovisualization can have more than 1,000 lives. So what is exactly augmented reality? Augmented reality is a mixture of reality and virtuality, which allows real reality to be expanded with additional information. So it's like you can show and represent one virtual object with the help of devices. It could be mobile, smartphones, laptop, computer, and etc. What is the aim of this topic and this new technology is it's a system which combines interactive reality world with interactive computer-generated environments. So the result represents a single environment. This picture is very important, and everything will be more clearly after this. So you see one line, and you see one line on the left side is a real environment. So for this, we are now real in the real room, and the right side is a virtual environment. So augmented reality is in the middle of this line. Augmented reality is near to the real environment, and augmented virtuality is more near to the right side. With these two pictures, we can make this more clearly. So on the left picture, you see real environment and one virtual object in that real environment. But on the other picture is real object, so person, in a virtual environment. Our task and our job is the picture number one, augmented reality, that will show later. For this new technique, new method, there is some requirements that we without gyroscope, GPS system, camera, compass, accelerometer, we couldn't or we cannot use this system. And most of smartphones these days have already incorporated all these things, and we will show it later. A little about applications. Of course, without applications, we cannot do this. There are some of them. First, I want to say that Unario AR browser is the biggest and most important from all applications that we can download from the Google, iOS, Apple Store, etc. So it's Unario is German. It's made by German company Metaio. It supports 3D-dimensional object, location-based companion with markers for identifying images, and it provides publishing and posting services for the content of the publisher. The second one is Lyre. It's very, very similar with Unario, so it has the same these characteristics. And the third one is Wikitude browser, and it's a very, very bad news for the people whose job is tourist guide, because with this application you can, if you are a tourist in some city, for example, now in Istanbul, we are all here tourists, and you can scan objects, for example, Hagia Sophia, and these applications gives you all information from the Wikipedia about that object. So the big story about this. So about that, it's very useful. Also, there is some applications like Google. With that application, you can scan for example, the name of one book, and then you got information about the synopsis, the content of the book, what's going on there.
Are classification systems. Similarly to virtual reality system, different classification of VR system can be made focusing of hardware of VR system, working distance, visualization approaches, or communication. By combination where the images will be showed, and also different visualization approaches. The classification is made on monitor-based system and also see-through system. About monitor-based AR system. Monitor-based AR system allows the user to observe the real world and superimpose virtual objects, thus without need to wear special glasses. This approach is widely used in laboratories for testing systems and also for low-cost demonstrations. This figure shows the setup of the system. The video images from the real world are enhanced with virtual scene, and also they are visualized or showed on screen. Also, it is required to know the exact position of the object. Display positioning or area classification. Wire displays may be classified into three categories based on their position between the viewer and the real environment. We had a head-worn, handheld, and also spatial system. First group is head-worn system. Visual displays attached to the head include the video optical see-through hand-mounted display, virtual retinal display, and also a head-mounted projector display. Current drawback of the head-worn display is the fact that they have to be connected to graphic computers like laptops, and it means that they are restricted by their mobility and also about battery life. Next group is handheld system. This category includes handheld video optical see-through systems, as well as handheld projectors. And this category of display systems is bigger than head-worn system, and also it is the best workaround to show our possibilities to mass market because of low production cost and also easy of use. And the last one from this group is spatial augmented reality. While head attached and handheld system support mobile applications, this one don't, but however spatial displays can currently provide higher quality and also more realism than can be achieved with mobile applications. This is the basic structure of the see-through AR system. And first from this group is optical see-through. Optical see-through, the principal schema of this display positioning system is shown on the picture from the left side. Namely, the virtual scene is projected at the view of the user, and also it's very important to take into consideration the position and the direction of the head of the user. And as the user moves, the virtual object has to be regenerated according to the new position of the user. Second one from this group is video see-through system. This group is cheapest and the most and easiest to implement, but also this group can provide reality to be digitized. It means that it's easier to remove or replace some of the fiducial markers or placeholders with the virtual objects. Last one from this group is projective display. For this group, no special glasses is needed. It has a wide field of view and it often goes in combination with the head-mount system. This group will be shown in the next steps of this presentation in practical part. And when we are talking about combination or integration of AR and GIS, we can initially extract these two categories into indoor exploration of geographical data and also outdoor exploration of geographical data. Also, there is different classification which is much more specific to the joint use of augmented reality and GIS, and whose initial aim is to describe and compare. That is the reason why we need to distinguish between the source of information and also its representation. There are two separating applications in this group, in two major groups. The first includes application which aim is at managing geographical data, and in this point we are referring to augmented map functionality. And the second one characterizes application which aim is at enabling users to work more efficiently in their environment, and in this point we are referring to augmented map functionality. About augmented territory, the augmented territory, the goal of this type of application is to provide additional information to the user to explore natural environment. This type shows, for example, the streets, the names of the streets, and street names and numbers, names of monuments, and other important geographical things. We here on this picture we have some of the application of this display positioning technique. And about augmented map, the aim of application of this type is to enable one or several people to explore geographical data which are coming indifferently from digital or the physical world. Here we can see some of application of this category, and also important for augmented territories that retiming is carried out by combining GPS for the position and internal navigation for orientation. Access to data for this augmented reality is by Wi-Fi.
Okay, first of all, let me introduce myself. My name is Dejan, and my part of this presentation is going to be a project part. And first of all, I will tell about how we are getting orientation and coordinates for our device. As my friend mentioned before, most of all of smartphones and nowadays devices, they have already incorporated accelerometers or GNSS instruments, so we are getting information of coordinates of those devices. So first of all, we need the exact location for our device, and we are getting through positioning of that device. My next couple slides will be I'm going to explain you how we can detect marker which we are using in augmented map. So there are a couple steps which every algorithm in camera are dealing with. So the first one you can see on the top left side of this picture, the camera scans what can see and all the polygons, and it detects at the top is the right picture the borders of the markers. Third step is that there is another scanning step where it scans the polygons which are overlaying under the above the markers, and the last one is definitely define the markers. So are we dealing with some steps which are collecting pictures, processing the detection of specific markers, and rejecting the objects which are not markers, and identification markers, and we have to solve right position of marker. So first of all, I want to say that we have two types of marker. First one is RGB image, which is red, the green, blue image, and the another one is black and white image. So the result is that we are, the result is that we have to convert, if we are dealing with RGB image, we have algorithms converting RGB to white and blue. So we have grayscale image, and we can define, for example, that white and white parts of the image can be 0 in binary system, and the black parts can be 1, and the colors between white and black are a combination of zeros and ones. So we are detecting, the most important thing is to detect the border of the markers. So the pre-processing means that when we scan the RGB image, the next step is that we have to convert the image in white and black, and afterwards we have to locate our marker. So how algorithm detects it? He has to know geometry of marker, and every marker has quadrilateral geometry, and it has to have some patterns inside, and it uses gradient orientation to detect markers. So we have to use a line detector algorithm, which detects the which is resolving the gradient orientation of the image, and when it detects the line, the pixels which are defining the line, sometimes it happens, I mean every time it happens that some outliers define some another lines which is not comfortable for our image and the border of the marker. So runs SEC algorithm removing outliers, and then we are getting our real marker. So sometimes happens that on the marker algorithm cannot detect all the line, all the length of the border. So a line detection is something like this, that algorithm already defines the gradient orientation of the line, and you can see the yellow pixels, and here if the pixels, if the gradient orientation of the pixels is same as gradient orientation of the red line, he extends the border for each pixel, and the last pixel, the corner pixel is a different gradient orientation, and it defines it as the corner orientation. So I'm talking too much about gradient orientation, and I want to explain you in this slide what does it mean, gradient orientation. If you take a look on the left side of this picture, you can see in the middle of the picture there is a black dot. So all directions from every part of this picture are going into the middle of this image. So gradient orientation unit is in degrees, and every direction is different from every spot of this picture. And on the right side of this picture, there is a line which is moving on the left to the darker side of this picture, and the pixels from the right side to the left side are, the gradient orientation is same. So you can assume that somewhere the line is separating the black and the white part, so gradient orientation defines the board of this image. If we are dealing with marker position, we have to know exact location of camera and exact location of marker. So there is 6 degrees of freedom for camera, 3 translations and 3 orientations, and using matrix transformation, which explains exactly ideal image coordinates, we can approximate our 3D model. If that 3D model, I mean, every 3D model has own orientation, and we want to make sure that 3D model is rotated as well as our marker. So we are multiplying the matrix, which is consisting of parameters of 3D model, and we are getting exact orientation of 3D model. So this is the maybe last, maybe one slide. Yeah, it's not the last, but one before. So how we can make our reality augmented for programmers and for non-programmers. If we want to make some Android application, we have to have some experience in Eclipse, Android SDK, and Metaio SDK, or Wikitude SDK, or Lyre SDK. If we want to make our application on Windows platform, we have to know some experience in Visual Studio and Metaio SDK. For iOS is similar. For non-programmers is something like plug and play. It's web programming. We are web publishing in Live Creator, desktop uploading Metaio, and Wikitude publishing points of interest. So our first project, I'm going to show you, if you was following me, about quadrial marker black and white detector. And using this application, I'm going to show you how we can augment our reality. Let me start up this program. So, as I said before, we are using camera, and we are using our marker. Yeah, it's kind of dark. Can you see it? Oh. Oh, it's okay. It's dark, so I hope that it will be working. But let me show you. Yes, it's too dark. Yeah, as you can see, this is the temple of Saint Sava in our capital city, Belgrade. It's the largest city. It's the largest temple in our country. And I'm going to show how we can manipulate this 3D object. So I'm going to turn on the, don't do that. I'm gonna size up this 3D model, and I don't want to hold this marker anymore, so I'm going to freeze this model. Okay. So I don't need anymore this marker. I'm going to do something else. I don't need anymore this photo part, and I don't need anymore the small church. I want to see white frame of this model. I'm gonna run white frame. I want to flip it over on one side and the second side. I want to rotate, for example, 3D model using one. Or is it enabled? Yeah. It's not working. It doesn't matter. What else I can do with this 3D model? I can I can set the brightness of 3D model, but my camera is not such a good. It's laptop camera, 2 megapixels, so I cannot do the light mode. I want to switch off white frame. I can animate. I can put the sound. I can, as I said, switch off all layers. I can put it back, and I mean that's the first of our project. And the second one is augmented map. So I'm going to use application. I mean, you have to have your own internet connection. And first of all, I'm going to connect with my laptop. So I'm going to switch off. I don't want to see my password.
while he's doing that settings, we will show you on this map. This is map of Serbia, and we choose the inner cities of Novi Sad, Belgrade, Kragujevac, Niš. The main, not the main, but the most significant objects. And with the mobile phone, we are gonna going down and scan this map city by city. And as you saw this temple of Saint Sava on this marker, also you will saw here the temples and statues that we have chosen to be shown. So the internet is slow.
I mean, we are using
There is no
free version of the web. My device is connected. No, I don't want close connection.
There's a light.
Okay, I'm gonna run one application. Okay. You. Facullty. Here. So I'm using Wire application, and I'm scanning my and I'm getting something. Yeah. So we augmented our image, and we get our legend. We do some play with this image, so we can enhance our image with some YouTube video. We can go and see something that is interesting. This is like for tourist attractions, so I don't want to play this music too much. We can go and see the legend, scale of this, and everything else. Serbia website of our Geodesy web portal, and this is a Facebook link to like this page. Show real quick. I mean, it's delaying. I don't know why. I said it's free version of this application. I mean, we made everything. Everything that you can see over here, we was dealing with free versions of applications, so we have limitations, and we cannot do. Can use options, which is much better for. And the beautiest part of this presentation is augmented mapping using Unio application. I'm going out. I'm starting another application. Okay, so let's do it. This is the monument of King of Constantine, which is born in our I don't know,
in city of Niš in Serbia, and it is in the city center.
And this is the monument.
Yeah, this is the monument in Kragujevac in one mountain, and it's a very significant historical monument. In our history is really huge, and this is a sign of one class where the whole class were killed during the war, and all children in that class, and in honor of them, that's what you have. So that's what you're gonna see is Serbia is an Orthodox country, and this is the greatest temple, the most significant temple in Serbia. Actually, it's in Kosovo, and Lučani is the name of that temple.
It's UNESCO protected.
Yeah, it's protected by UNESCO.
I'm not fine. I don't know why. Yeah, there you go. And one more, and so okay, this is our final city, and we're gonna show you our government building of Vojvodina.
Yeah, Vojvodina is the
Nešto se
northern province
pokučilo.
of Serbia, and then what you're gonna see is a parliament of Vojvodina. So there is a lot of space for this augmented reality to make it better. A lot of perfections like connectivity and the speed. So thank you very much.